Hello everyone, good morning. In this video I am going to explain our final year project. There are 4 group members in our team, including me, Divya Ghate, Sachidananda Linge and Rahul Mahajan. On the behalf of my team, I am going to explain this project, and our team is guided by Dr. Jyoti Deshmukh ma'am, and our group ID is IT 2020-13-18. So our project title is Machine Learning Based IoT Network Intrusion Detection Classification System. So what is the idea behind choosing this topic? So, in the recent years, IoT-based systems have been used in improving the experience in many applications, including healthcare, agriculture, supply chain, transportation, and etc. However, there are various attacks that are performed on these IoT devices. So, we are developing an ML model for classifying these attacks into the 9 types more specifically, and our model can take decision on the basis of the attack performed to the system and tell us that the attack is normal or harmful to our system. So we are going to use these 4 ML algorithms for training our dataset. We are going to use UNSW NV15 dataset, which are available on the Kaggle website, and after that we are going to import some libraries here to perform some actions on that data set. Here are pandas, numpy, seaborn and matplotlib library. Using this library we are going to perform basic actions on the data set. Here so our project is divided into the more 4 modules. So the first one is data pre-processing. So in the data pre-processing step, we are going to clean our data set. We are removing the non values from the data set, means whichever are the empty fields, we are going to remove that, because after removing that our model can take precise decision. The second one is responsive feature. Responsive feature means our model can tell us that the attack performed on the system is normal attack or the more harmful to the system, and after that this system is going to, means model is going to tell us the classification of the 9 types of attacks. After that model selection, in the model selection we are going to train our data set using the 4 ML models, and the last one is model comparison and inspection. In the last step we can compare the all the above 4 ML models, and which model give the best result, we are going to use that. So here we are going to pre-process our data. Here we are loading our data and reading the data set. After that we are going to remove the none from the data set. After that we are going to divide our data set into the two. First one is training data set and the second one is testing data set. So we are keeping 70% of our data set for the, here we are keeping 70% of our data set for the training purpose and 30% of the data set for the testing purpose. So after splitting the data set, you can see here are the uh, 1 minute. So here are the result. So here we can classify our so here we can classify our attacks in the 9 types. You can see here the 9 types are normal, backdoor, analysis, fuzzers, shellcode, reconnaissance, exploit, DOS, worms and generic. After that we are going to divide our dataset into the two parts. First one is for the training purpose and second one is for the testing purpose. So we are going to train the 70% of the dataset, and for testing purpose we are going to keep 30% of the dataset. After dividing the dataset we are going to train our model. So here are the various ML models which are taking actions on the data set. So steps for the training model. Here is the first step: train a ML model and validate it via cross validation. The CV result will show how good the model has been trained by using the training data given a set of hyperparameters in the ML model. The metrics of evaluating a model include accuracy, precision, recall, F1 score, AUC value and ROC. And in this step 2, evaluate the model by using the testing data. It will show how good the model could be used to make prediction on the unseen data. So let's firstly train a logistic regression model with regards step 1 and step 2. Here we are training the data set using the logistic regression algorithm. So you can see the results here. Here are the several methods ML models that are performing on the dataset: logistic regression, decision tree classifier, random forest and multi-layer perceptron. So I can give a short idea about these ML models. In logistic regression is one of the most popular machine learning algorithm which comes under the supervised learning technique. It is used for predicting the categorical dependent variable using a given set of independent variable. So the logistic regression gives the result in boolean, means 0 or 1s, or the attack is happen or not in this type. So it is not more accurate and precise. In the second one is decision tree. Decision tree is a supervised learning technique that can be used for the both classification and regression problems, but mostly it is preferred for solving classification problems. It's a graphical representation for getting all the possible solutions to a problem or decision based on the given conditions. The third one is random forest. Random forest algorithm is a classifier that contains a number of decision trees on various subset of the given dataset and takes the average to improve the predictive accuracy of the dataset. The greater number of trees in the forest lead to the higher accuracy and prevent problem of overfitting. And the last one is multi-layer perceptron. A multi-layer perceptron is a feed-forward artificial neural network that generates a set of output from a set of input, and MLP is characterized by several layers of input nodes connected and redirected graph between the input nodes and the output layers. So here is the first one for the random forest, and we are going here is the model comparison. So in the model comparison uh, we are going to compare all the above four models, and here are the values on which basis the model is compared. So which model gives the right fit for the data set, we can choose that model. Here are the result of the data set is being trained on the above four model. You can see here random forest, decision tree, multi-layer perceptron, and logistic regression. Here you can see the multi-layer perceptron gives the highest fit time for our data set, and the highest accuracy is also given by the multi-layer perceptron, because in the multi-layer perceptron we are going to use the deep feed forward neural network. It is an advanced system in that our data set can give more accurate and precise value, so it is the best fit for our model. So here we are going to the inspect our model. So in the inspection, determine which model should be used to clarify category attacks and network intrusions on IoT network. Also discover relevant feature for model inspection. So here you can see the result. Here are the graphical representation of the attacks that are normal or more harmful attacks based on the logistic regression. You can see the output here. Here is the partial dependency of the attack on the basis of logistic regression. So model selection refers to the process of choosing the model that best generalized training and validation set are used to simulate unseen data. Overfitting happens when our model performs well on our training dataset, but generalized poorly on the testing dataset. So you can see that random forest will work on the best fit of our project. So we can using this random forest and algorithm, and here one for the second logistic regression, it is also used for the more advanced purpose for permutation feature. So you can see the result of this here. And here is also permutation importance on the basis of logistic regression algorithm. So here is the overall project. So what is the future scope of this project? So, to minimize the future risk, it is considered that the need for the further research that relies on threat detection becomes a reality in that sense, and that their security issues such as privacy, confidentiality have been recognized and must be resolved and prevented. The future work will be adopt an ensemble model with a novel dataset suitable for the IoT environment. In addition, this approach can be enhanced in the future by incorporating deep learning models. More specifically, the BOLT IoT dataset will be utilized for experimental analysis and compared to the UNSW NB15 with a deep learning model for a network traffic classification. So the conclusion of the project is we are going to develop a method propose research work analysis with the different type of attacks in the IoT, and propose a hybrid convolutional neural network module by incorporating long and short term memory process. Proposed model is experimentally verified and compared with conventional recurrent neural network, and attains better detection accuracy of 98%, which makes the application suitable for different IoT environments. So here is the overall project. So thank you everyone.